Hello, everyone, and welcome to today's LFH webinar on bringing the cloud experience to the factory floor with Project Eve. I'm Sunny Tsai, Marketing Manager at the Linux Foundation, and I'm excited to be your host today. So before we get started, just a few quick housekeeping notes. This webinar is streamed live on LinkedIn, and it's also being recorded. You will be able to find the full recording on the LFH YouTube channel after the webinar. If you have any questions for our speakers during the webinar, feel free to drop them in the comment section on LinkedIn at any time. We've set aside the last 15 to 20 minutes for Q&A, and we'll do our best to get to as many questions as we can. So as a reminder, this is an official Linux Foundation webinar, and all participants are expected to follow our code of conduct. So please keep the discussion respectful and constructive throughout the webinar. So now onto the exciting part. We're joined today by two leading experts in edge computing. First, we have Micheal Maxey, VP of Business Development at ZEDEDA. Micheal leads ZEDEDA's go-to-market strategies and also serves as the board chair of LFEdge, helping shape edge computing standards and solutions across the industry. He also sits on the steering committee for the Linux Foundation Margo project. Also joining us is Ashwin Gopalakrishnan, Solutions Architect at Dianomic Systems. Ashwin brings over 20 years of experience in computer engineering with a strong focus on industrial solutions. He has been instrumental in helping organizations deploy scalable systems at the edge. So with that, I will hand over to Maxey and Ashwin to kick off today's discussion.
Great. Thank you, Sunny, and I appreciate everybody's attendance today. And as mentioned, please send your questions. We're saving a bunch of time at the end. So I'm going to talk a little bit about Eve and sort of its history, and then I'm going to hand it over to Ashwin, who'll talk a little bit about Fledge. And then at the end, we have a demo. So please stay tuned and stick around for the demo. We'll show you how the products come together and how you can try it for yourself. So let's jump into it. Let's start with kind of why Eve exists, right? So, we set out to build Eve about 7 years ago, and we built it really for what is now today known as edge computing. And that is a very different environment. If you're new to the edge, you have to deal with constraints that aren't persistent in the data center or the cloud. So think about taking a device out of the data center. How do you protect it? If it's at a very remote site, say on a shipping vessel, how do you update the software? How do you access that device? And then also, you end up with a ton of diversity on the edge. Unlike the cloud, where things are sort of built in pizza boxes and very consistent across your different workloads, on the edge, you see all kinds of different hardware, you see different applications, you see different open source tools. So we really needed a bare metal operating system that allowed us to address all of these different requirements. And that's why we built Eve. We couldn't just take a standard Linux distribution and try to push it to the edge. We needed something purpose-built. And we'll talk a little bit more about what that is. A little bit of history around the journey and how we built Eve and where we are today. So when we started, we thought that we were going to build unikernels with containers on top. That was bleeding edge technology. It was very lightweight. And as we started talking to industrial and enterprise users, what we learned is they're still running Windows, often very old versions of Windows and virtual machines that are connected to assets in the plant or assets in the field that aren't being containerized, aren't being modernized. So the first thing we built was actually support for Windows VM. We rolled that out to a number of our users, and they quickly came back with, hey, how about some containers? So we added Docker support. Then security became a very big issue. So we added firewall support and then network connectivity. And then as we've matured over the last 7 years, we're starting to see more and more technologies. So we've implemented, Docker Compose, because you start to have a few containers. And more recently, we're seeing more and more Kubernetes. So we're starting to see Kubernetes become the dominant platform for container management on the edge. And Eve has, over time, built support for all of these and other different workloads to allow our users and our consumers to really run the workloads they need and manage the assets that they need around that. So just a quick history on Eve, starting with Windows, ending at Kubernetes. We're also excited to announce that Eve has reached stage 3 inside Linux Foundation Edge. What that means is it's a top-level project, and the stage 3 is really reserved for projects that have shown a fair amount of market traction, that have shown a fair amount of adoption in open source, and have satisfied a long list of requirements around security and visibility and accessibility. So there are a handful of projects at stage 3, Fledge being another one, which we'll talk about here in a few moments. We're excited as a project to really see this next step. A lot of that was driven by commercial adoption, of which you can see sort of a screenshot on the slide here, but it's also kind of adoption across the industry. We did publish a blog post. We can share that link after the webinar. So if you want to read more about why we're in stage 3 or how we got there. But as a team, we're very excited to reach this stage. It's a big milestone for Eve after almost 5 years in the Open Source Foundation. We finally made it to that stage. So let's talk a little bit about what is Eve, right? And Eve stands for Edge Virtualization Engine. In effect, it is an operating system, but it's not a traditional operating system like you might think coming out of the Linux Foundation. Instead, it's very lightweight and purpose-built for devices that run outside your data center. It includes an embedded hypervisor, which allows you to run all sorts of different workloads. As I showed kind of in our history, we've supported everything from Windows to network functions and beyond. And it's also built for environments, where you don't have IT staff and you don't even have maybe a building. We have users that deploy our technology at sites, solar sites, for example, or windmill sites where there's no cabinet, there's no IT people. So protecting that and making it available via zero trust and zero touch is very important to our users. That's been a feature since day one. It leverages, modern technologies and techniques you've seen in maybe networking around TPM and measured boot. Your cellular phone or mobile phone probably uses the same technology to protect your applications. But fundamentally, this was designed for edge environments. And that means it needs to run in a really small footprint. So Eve itself consumes one virtual CPU and about a half a gig of memory, leaving the remainder of your system available for all the applications and workloads that you need to run at the edge. If I double click a little deeper into kind of the architecture around Eve, the first thing I would state is, it's an immutable OS, which means you don't log in and configure things, you don't add users, you don't change permissions. Instead, it's all managed from a cloud console or a local console. And the OS itself is immutable, which means it can't be tampered with. It's a read-only operating system is the way to think about that. We also disable standard connectivity that you would expect in a data center. You can't console into Eve. You can't SSH. We disable ports. You can't plug USBs in. And we do this really for security reasons because these devices often live outside the data center. With Eve, you can virtualize up all the hardware in your device. Everything from legacy protocols like Serial, all the way to modern satellite connectivity, and all of that is available to sort of distribute across your different applications with rules and firewalls and all of those things behind it. It's also really been designed to never brick your device. Like the worst thing that can happen is you brick a device in the field and it can cost you tens of thousands of dollars to fly an IT person there to fix it. So we have, capabilities like dual partitioning, which means that when you upgrade an Eve node, or if you maybe change a network configuration, we try it in a second partition, we make sure it functions, and over time we fail over to that new partition. And this prevents you from maybe pushing a bad network config and losing contact with your device and in effect bricking that device. So there's a lot of capabilities around remote support, around security. And then the last thing I think is important is, Eve's pluggable architecture. So, most of our users prefer KVM, but we support other hypervisors. We can build it out of other Linux distributions. It really is sort of a flexible, lightweight edge operating system that gives you the ability to kind of build as you like. And of course, all of this is open source. It lives in LF Edge, Apache licensed. So you can download the source code, or more importantly, you can join the community and help us improve Eve as we move forward. So speaking of moving forward, I talked a little bit about our history, but we've recently done a number of announcements and releases via the LF Edge. And we've been adding some new capabilities I wanted to highlight. Um, the first is around, bringing in AI workloads, and I'll talk a little bit more about that. But obviously, that's very important to the industry. A lot of focus around AI these days. Part of that is running on GPUs, running on systems like Jetson from NVIDIA, and being able to support the diverse workloads. So Eve supports all of these workloads. We can use GPUs. We can run on GPU-based systems. And all of this is the same functionality as an Intel system or an ARM system. We really support all of the different major chip manufacturers. We also added a high availability characteristics. So we've had customers that want to run small clusters at the edge. Think of maybe a point of sale in a retail environment or a highly available AI app. So we've added a 3-node clustering capability, which gives you storage redundancy and the ability to sort of fail over if one of your nodes has an issue or a hardware failure. So we've added high availability as a new feature, and we do that across 3 nodes with a kind of a control plane implementation. So lots of new features coming, long roadmap for Eve. It wouldn't be a modern presentation today if we weren't talking about AI. And I wanted to just spend a quick minute about Edge AI. One of the things I think that's, a couple big characteristics that's different between the cloud and Edge when it comes to AI. In general, you see most of the model building happening in the cloud. This makes sense because you have elastic compute capabilities, and training and building a model requires a fair amount of processing. Once that model is built and you want to do inferencing, which is using the model to kind of get the output, that's typically done near the data, which in our world means at the edge. And doing AI at the edge and inferencing really solves a number of problems. It gives you, local data privacy, so you're not maybe shipping data out of the EU or opening up some of your privacy data to the internet. You can just process it locally on your environment. It brings you ownership and trust against that. And it also gives you flexibility. Your sites may vary. You may have different lighting characteristics or different machinery, or even an entirely different setup across your different sites. So running it locally gives you the ability to kind of customize and tune those models, tune those workloads specifically for those environments. A little bit different in the cloud where everything is very homogeneous. And what we're seeing across our users is, kind of a combination of microservices and AI models starting to show up as, a combination of workloads on top of a single device. And if you think about it, you really do need to account for more than the model. In AI, models get a lot of attention. Our cloud company partners announce new models all the time, but it also needs a data engine. It also needs the ability to take action when the model finds something. You generally need to protect this with a firewall. So what we're seeing across a lot of our users is a high mix of different workloads running on these devices. So the model itself, there's generally microservices running around it, data protection underneath, and Eve helps with that. We give you the ability to kind of virtualize all those workloads and run them on one or more nodes, and kind of deliver that whole system of inference at your edge. And all of that is built on sort of our secure operating system and connectivity back to the cloud. So you can do this at scale, meaning hundreds to tens of thousands of locations. You can manage all these different AI clusters and the way the data interoperates and acts against your different AI models. So obviously a lot of interest in AI, and Eve is really sort of pushed forward into that environment. Last thing I wanted to talk quickly about is a free resource for any Linux Foundation member. All you need is an LFID, which is free to get, and it's called the LF Edge Sandbox. And we're actually going to use this for a demonstration here in a couple minutes. But this is a free online utility that anybody can sign up for and help you experience edge computing. So this is sponsored by LF Edge. In there, you'll find a number of the projects we're talking about today, so Eve and Fledge and others. But this is a self-service sign up, and you can experience edge computing yourself. We even also have a library or a pool of resources. So if you don't have a hardware device, you can actually reserve a hardware device from LFEdge and run the LFEdge sandbox against it to get that full experience. So if you're interested in trying out Fledge or really any LFEdge technology, we'd encourage you to sign up for a sandbox account. Again, it's self-service and well documented, and allows you to experience this edge computing piece firsthand. So with that, hopefully you have a good understanding of Eve and the sandbox. I'm going to hand it over to my partner here, Ashwin, who's going to take you quickly through Fledge and then dive into the demo. So really appreciate your attention, and do send your questions. With that, Ashwin, I'm going to hand it to you.
Thank you, Max.
Got it.
And thanks for that introduction into Eve. Now, Fledge, if Eve then secures your gateways and your physical presence at the edge, then Fledge is the application that will then allow you to create industrial data pipelines at the edge. In the past, your presence at the industrial edge was typically just a collector. So imagine at the industrial edge in your manufacturing floor, at a power generating station, at remote sites, you have assets that you need to monitor. You have processes that are in play, and you need to get data for that. And for decades, the edge presence has always just been a connector that may connect one protocol, that may connect one asset, and make that data available through another protocol, or send data to a cloud or to a database. And the presence at the edge has been mainly just minimized into that technology. With new applications and with new problems that are emerging, Fledge is there to expand your presence at the edge to do much more, and to create intelligent data pipelines from your point of data collection itself. So Fledge is a technology, it's an application that lives out at your industrial edge as close to the asset as needed. It can collect from multiple data sources in parallel, so multiple PLCs, multiple sensors, multiple IoT systems. It can send data to multiple applications as well, so to historians or to databases, to cloud data stores, whatever it may be, in parallel, and then create applications at the edge that transforms that data, that informs others based on analytics that are happening at the edge. And of course, doing so while integrating with all of the latest and greatest technologies that are out there in the cloud and on-premise. So if you're going to introduce a new technology, a new application that's going to be more robust at the edge, your new presence at the edge has to be able to support the typical time series data that we're all used to, sensor values like temperature over time and so forth, PLC data points. It needs to be able to handle high frequency data. Fledge is able to ingest raw waveform data in the kilohertz levels, for example. You need to be able to ingest array data, image data coming from IP cameras, or radiometric data coming from infrared thermal cameras, acoustic data and transactional data as well. So not only do we support the typical data types that you've seen in the past few decades, but much more. You need to be able to create new applications at the edge, ones that process those signals. So fast Fourier transforms and so forth against raw waveform data. You need to be able to collect and aggregate that data. You need to be able to write back using set points back to the data source if needed. So in a demo in a little while, I'll create a virtual sensor value, and we need to be able to bring that value back to the edge, to the assets and to the people using it. And we need to inform as well. And so for all of those reasons, there's a requirement to have a stronger edge presence, more than your typical connectors that you've used in the past. And Fledge is your Swiss Army knife at the edge to create new workloads in the edge in that way. Our architecture of a single Fledge is such that each of these green boxes is a microservice, and each of the blue boxes is a plugin that, when attached to a microservice, is created a new workload. So a south service is responsible for getting data from those data sources, and we support multiple protocols via these plugins. We have a Modbus plugin to create to Modbus data sources, OPC UA to connect to servers that support that protocol, MQTT, HTTP, directly attached sensors, and so forth. The Nord service is responsible for sending data to different destinations. So we have protocols via plugins that support sending to historians, to clouds, to MQTT brokers, to Kafka, whatever it may be. And we have filter plugins that can be attached either as data is coming in through the South service or as data is going out through the North service. That helps transform that data. And now these filter plugins could operate on the data to do something simple like scale values or reshape data. It can do more advanced signal processing like ML and AI at the edge, FFT or RMS against raw waveform data, image classification, whatever it may be. Can do other applications like compressing some amount of that data so that you're not throttling your integration or your northbound integration point with too much data if you can help it. And so that's what creates the workload in terms of transformation. We also have an event service, which helps you create alarms out at the edge. And an event service is made up of two plugins, a rule plugin to determine if an event has occurred, and an action plugin, which determines what action to take once that event triggers. And again, these are plugin based also. A storage service exists so that you can buffer readings. In the case of intermittent connectivity, if you have a remote site that only comes up for half an hour in a day, but needs to collect data for 24 hours continuously, you can do that such that 24 hours a day you're collecting data, and then that half hour where you have access to the internet, you can send to your cloud endpoint, for example. And then a set point control service that allows you to write back values to the PLC or to your data sources to write back to whatever's connected on the south side. So not only are we allowing for data to come in and send through the north, but we're allowing for bidirectional data pipelines in this manner. And all of this is exposed for configuration via REST API. The Fledge GUI that I'll show you through the demo leverages the same REST API. But of course, you can tap into management tools and so forth to help automate your configuration of these fog lamps, or these Fledge instances as well. Like I said, you can collect any data using these plugins. And one important point to note is that we've built the infrastructure for this platform, and plugins are available for anyone to build. Meaning if you want to build your own South plugin or North plugin or filter plugins or event and rule and action plugins, you can do so because we've published the API to create plugins on our documentation. And so anyone can create these type of plugins using either Python or C++. And of course, on the Fledge IoT repository, there's numerous examples of those plugins, and documentation is also there to help you along with that. Fledge can install on bare metal devices, virtual machines, containers, Kubernetes, cloud, or on-prem. And that's why it helps you create a data infrastructure, a data fabric in that way. Sorry, I must have missed that slide. Essentially, you can create and deploy Fledge as close to the assets as needed to solve any particular problem that you may have. You can use Fledge as a data relay as well, so that one Fledge can send from one instance to another Fledge to have data hop from one network point to another before it ends at its final data destination. And supported OSINT platform, Debian, RHEL, Ubuntu, across x86, 64, ARM64, and ARM32. All of the delicious gateways that we're used to provisioning and installing on, and have support for in Eve as well. And so from here, I'm going to jump to the sandbox demo that we have. As Max explained, LFEdge now hosts a really robust sandbox in which you can provision a gateway. If you don't have one yourself, you can get one from LFEdge itself, have Eve running there, and then have any type of application that you want containerized or VMs running there as well. And so I'll show you an example of that now. Okay, so the LFEdge sandbox, just to get started, is really easy to use and get started with. The first thing you do is go to the LFEdge sandbox link and simply set up an account if you don't have one already. And as it states, you can either use an Eve-compatible device, which they have a large list of compatible devices, or you could provision or reserve a community lab instance that they have set up in the lab. Now from there, once you set up your account, you'll be met with this type of interface, the LFEdge dashboard with your account name and so forth. And from here, you can book a pod, which means you can reserve an instance that is already here for you to use if it's not already in use. I already have one booked. And so I'll go to my bookings and I'll be able to see the instance that I had there. And so on May 2nd, you can take over my instance and play with this environment yourself as well. And then from here, once you book the instance, you'll have Eve installed on that instance itself. And once all of the provisioning is done for Eve, you'll receive in your email credentials and information on how to log in to the sandbox control environment that's provided in this LFEdge sandbox. From here, you're looking at everything that you need to configure and to deploy applications to that device that has Eve installed. So this is your controller for your Edge instance. From the dashboard, you can see that I have one Edge node. That's the box that I provisioned in the LFEdge sandbox. I have my Edge app instances. These are all the apps that are running. I have Fledge here. Foglamp is Fledge. I have a couple of simulators. I have a Modbus simulator, and I have a Mosquito MQTT broker to send data to. And from here, you can see the library. The library is interesting because this is where I first load all of my applications that I want to run. So I have Fledge here, Foglamp, as an application that I've created. It specifies which image to use from Docker Hub. If I have a custom image, I can do that as well. And I give it some basic information here. In addition to that, I did the same for the Mosquito MQTT broker for Grafana, if I wanted to, the Modbus server, Nginx. And the list is endless in the type of Edge images that you can create. From there, I can go to the marketplace and see the Edge applications that I can create from that. And so I've created this Foglamp or Fledge application here. And within Fledge here, I've specified certain port routing that I want to configure for my application so that the REST API that I spoke of before is exposed, and that the GUI for Fledge is also exposed. And then finally, my Edge app instance that I've created from my Edge apps here and the status of those deployed onto those Edge nodes. So once I've actually deployed this instance, then the sandbox control, along with a lot of the Eve utilities here, has allowed me to create some port forwarding and so forth so that I can actually use the Fledge GUI against the Fledge REST API on my desktop itself. And so from here, what we're looking at now is the Fledge GUI. The Fledge GUI is arranged in the same way that I described the Fledge architecture. Again, south of Fledge is where we're getting data from. In this case, I have a sinusoid data source, which just generates simulated data. And I have a Modbus server, the same one that I deployed on the same Eve Edge device as a container that I showed you before. I'm getting data from that as well. North of Fledge is where we're sending data to. And in this case, I'm sending to that MQTT broker that I also have running within that Eve device. And I have a connection to Azure in this case, just as an example. In my case, I didn't allow for data to exit my instance yet, so I'm not sending to the cloud in this case. But this is all to show that, as I described in the architecture, Fledge is that new connector that can bring in data from multiple places in parallel and to send to multiple destinations in parallel as well. Now, what I want to show here also is that within my Fledge instance, I have a few filters that I'm running. Now, filters are what allow you to create advanced workloads, intelligence and transformations at the edge. You can do things to process that data, to rename it, to shape it, to do analytics on the data at the edge. You can run ML models at the edge that are coefficient-based, but also neural network-based. And so you have a plethora of tools at your disposal to create whatever type of workload that you want out at the edge using Fledge. Now here, my Modbus data source, a lot of you are not familiar, Modbus is a typical protocol that is in the industrial world. And so you have assets, maybe a pump, and that pump has a PLC, a piece of hardware that's meant to control it and other assets that may be in that area to create this industrial workload. So the pump may be pumping water or industrial slurry, in the case of mining, whatever it may be. And this Modbus server is the piece of software in this case making data available for that asset. So the asset is a pump, and the Modbus server is making data available for that asset. So the temperature values, the humidity values, the pump flow values, all of that are contained within this Modbus server at the asset edge. And now Fledge is connected to that Modbus server and is ingesting data from it. So let's see what that means. Well, that Modbus server connected to the asset, this pump, has server IP. It has the port, the protocol, sub-protocol, Modbus has RTU and TCP support, and so does our Fledge plugin in this case. And then we have a register map or a tag list of what we want to get data for. And so we want to get the temperature for this pump, the humidity for this pump, the flow for this pump. Typically, there may be hundreds of tags to thousands of tags, hundreds of thousands of tags, in fact, sometimes depending on the data source. In this case, we just have 3 data points that we're ingesting into Fledge from this Modbus server. Now, in addition to that, if we look here, we can see the readings that are coming in. And if we go to the Assets and Readings tab of the Fledge GUI, we can see the most recent reading for this pump. And we can also trend the readings as well. It's kind of flat data in this case. The data that's being created from this Modbus simulator is pretty flat, but you can trend this over time. And the Modbus data is a little bit more robust in that sense. Or I'm sorry, the sinusoid data. Now back to the south, the one thing I want to point out here is I do have a filter connected to my Modbus data source. In this case, I'm using the expression plugin. Like I said, the architecture of Fledge is plugin based. So we have the Modbus plugin to connect to the Modbus data sources. We have an expression filter plugin that allows you to apply mathematical expressions onto data as it's coming in. And so I've said, I want to create a virtual sensor, and I'm going to name it virtual sensor, vSensor. And the expression I want to apply is the ceiling of flow times 6. It's very simple on this flat data for the data point flow. And so the assets and readings, when I apply that filter, show that it'll take flow times 6, and we have the virtual sensor value. Now, this is really simple in this case, but you can use that same expression filter to create a really large and complicated mathematical expressions if you want to. And in that same way, you can use any filter that we have within Fledge to create any type of analytics that you want out at the edge. And where a filter doesn't exist, where a plugin doesn't exist to connect to a data source, or to do a certain type of expression or transformation that you want, where a plugin doesn't exist, you can always create one yourself using plugin API in Python or in C++. Now, north of Fledge is where we're sending data to. And like I said, we can apply filters as data is coming in or as data is going out of Fledge. And in this case, I have a delta compression filter that is there to help reduce the data that's being sent out. So it can help in reducing the number of duplicate data values. So if you have repeating zeros or repeating values like that, sometimes people only want to send on exception rather than every single value. And so you can use the delta filter to do exactly that. And so let me enable that and show you that the moment I enable this compression filter, and I go back to the dashboard, dashboard's really helpful in seeing the data as it changes. The data should drop in reading sent. So we're getting the same number of readings received, but because my sensor values have so many repeating values, the number of readings sent will drop. And then we'll stable out at some point as well. We have, again, the notifications tab to create notifications and alarms out at the edge. The control tab to do set point control and aid in that. The configuration tab for general configuration of the Fledge instance, like the API security and so forth. The certificate store to store certificates that are used for securing the Fledge instance itself, but also for securing the connections to your integrations and to your data sources. So if you're securely connecting to Azure, the credentials for that could be stored here as well. A backup and restore tab to exercise the ability to back up this Fledge instance. A logging tab to see and troubleshoot what may be happening in your Fledge instance. User management support. The ability to create a support bundle so that if you want to create a support bundle and pass it off to somebody that has more expertise in Fledge to be able to do that, and so forth. And so that is the Fledge demo that I've set up here. Again, this is all running within the LF-Edge dashboard, LF-Edge sandbox environment within Eve. And this it's really a really cool way to get started with Eve and with Fledge, and to create new applications that are going to change your presence at the edge, where before it was just a simple data connector. You can create a bigger edge presence to create and solve new problems.
Awesome.
Very well done, Ashwin.
Yeah, thank you. Thank you both for the great presentation and demo. It's always exciting to see how LF-Edge projects are coming together to drive real impact in the industrial edge space. So for now, we're going to transition into the Q&A portion of the webinar. I did see that we received a couple of questions from the audience on LinkedIn. The first question that we received, I think this is more for you, Ashwin. Is there a Fledge plugin for BACnet?
There isn't right now. With that said, I'm sure there's an open source BACnet source code or driver in GitHub somewhere. And so if you want to create a new BACnet South plugin and contribute it to Fledge, we would love that. Of course, that would be something that we would highly support.
Awesome, thank you. And another question regarding Fledge. Does Fledge support ARM62 architecture and Debian Bookworm?
ARM64 is supported. Debian Bookworm in particular, I'd have to check, but I believe it is. Ubuntu 24.04, I think we are planning on supporting that soon. I think it may be in our next release, in our upcoming release.
Awesome. Thank you, Ashwin.
But to look at the full list of what's supported, you could always go to the Fledge documentation to see.
Fantastic. Sweet. And yeah, again, feel free to drop more questions into the LinkedIn comment section if you haven't already. There are a few questions that I have that I would like to ask you all. So the first one is, I think this one is more for Maxey. So you mentioned that Eve supports one of the largest Kubernetes production deployments at the edge with over 12,000 single node clusters in the field. That's a huge scale. What are some of the unique considerations or lessons learned from operating in that kind of environment?
Sure. Yeah. So great question. And these are single node clusters, meaning one piece of hardware hosting a Kubernetes cluster and a couple other apps as well. So obviously resource constraints are something to consider. You can't, or you could, but it'd be very challenging to deploy a full-blown Kubernetes distribution. So, one of the things you want to consider is sort of the weight of that, K3s or microkates or K0s are good options to consider to help constrain resources. The other thing I would recommend is really the scale side of it. A lot of the orchestrators that are available on the market for Kubernetes were built for a handful of very large clusters. What we have is the opposite problem. We have 12,000 single node clusters. So things like page refresh or logins can start to stress those orchestrators. So those are the considerations you'll have to think about is how do you scale the open source tooling around it? Of course, there are commercial offerings that I think can help with this from my company and others. But really, I think the considerations around resource and around scale. And then the third piece, which I think Ashwin touched on around sort of security, is also very important. Our users tend to be in the OT space, the operational technology space. They tend to be running production assets that are, trade secrets or algorithms they've built over time that are very valuable to the business. So you want to make sure that, as these scale out, whether they're Kubernetes nodes or not, that they're highly secure and available. So those are kind of the three things I think about: security, the size of the runtime, and then just the scale of management against the number of clusters.
Awesome. Thank you, Maxey. That was great. And I see that we received another question from the audience around Fledge. So how are AI models, both and statistical rule-based, implemented into Fledge?
That's a great question. The life cycle of such models is actually a really interesting story. Oftentimes, let's think about what's happened in the past. Like I said, for the past few decades, connectors have been implemented to be your only edge presence. So data was collected, it was sent to a historian or some end destination, a cloud, a database, whatever it may be. And from there, people would use the data that's already collected to create models, either statistical and rule-based or neural network-based, to create some results and do some analytics based on those models. Now, when you wanted to explore new problems that needed to be solved, sometimes those legacy ways of collection actually limited you from creating new models because they didn't have the fidelity of data that's needed. And they didn't allow for data sources to be merged at the edge, for example. And so the first thing to be said is that Fledge gives you now a unique opportunity to create these workloads out at the edge as close to the asset or the problem as possible. Oftentimes, these problems can't be solved after the point of data egress into the database or the cloud, but they need to be solved at the edge at the point of data collection. And now, second, what Fledge allows for is collection of data to first create training data that could be fed into your model training system. And so Fledge allows for that collection of training data. It allows and aids in helping of labeling that data as well when possible. And then from there, you may use, and that data then would be sent to a data science environment using one of our North plugins. So if your data science environment is in AWS or in Azure or within a database, send it there. And then your data scientists can then analyze that data, train a model, and that model can then be pushed back down into Fledge. And now Fledge is running a model that relied on data being collected at the edge, being trained in a cloud perhaps, or in whatever data science environment, and then pushed back down to the edge as close to the asset, which is where it needs to be run in a lot of use cases, correct? And so Fledge is really there to solve these type of new problems without the limitations of old legacy systems of edge data collection. And with that said, where the rubber hits the road, these models and the corresponding code is usually put into one of our plugins as code. So like I said, our plugins are there, are our modular pieces of code that could be reused and coded by anyone to create new workloads. So you can create plugins in Python or C++ that use those model files or rule-based systems to actually execute the code that's needed for that model to run out at the edge.
Yeah, so maybe to jump in there as well, Ashwin, I think the other implementation we've seen when at AI in the edge is using Fledge to build, collect, and tag the data, and then maybe handing it to a second container where the model can run. The plugin option is also very good. The one of the benefits or challenges that the separate container can bring is if you want to sort of do dual A/B testing, you can actually deploy two different models, stream data across the two, and do fine tuning. So there are a number of different implementations and ways of implementing AI through Fledge and ZEDEDA and Edge. I'm sorry, Eve can help support all those different workloads and run that. So a lot of flexibility, a lot of configuration on how AI can be managed in the field, and really great question. Appreciate that one.
Absolutely. Bringing that power back to the edge is definitely the most important part of this, because technologies that don't have this capability at the edge can't solve a particular set of problems that really gain that type of efficiency that's needed in the industrial sector for sure.
Awesome. Thank you, Ashwin and Maxey. And we do have a follow-up question on that. So I implement a model in Python or C++ and then deploy as a plugin to Fledge?
Yeah, you can. So our API to create new plugins is documented in our documentation. And we have numerous examples of those type of plugins in our GitHub repository. So if you have a piece of code that you've already written that you believe to be a sound piece of code for this model, you can just port it into a Fledge filter and then have it run within Fledge.
Awesome, fantastic. And keep the live questions coming in. All right, and the one question I have for you all is that, so we saw how Fledge plays a big role alongside Project Eve in handling industrial data. How do these two projects complement each other in building scalable and secure industrial data pipelines? And what are some real world use cases where this combination shines?
You want me to go first on that, Ashwin?
Yes, please. Yeah, I'll follow up with what I've seen as well.
Like if you think about a network stack, Eve is the bare metal piece of software you install on your hardware, and that can be everything from a Raspberry Pi to, a large Intel server full of GPUs. And what Eve brings is the ability to deploy different workloads on top, one being, of course, Fledge, right? So what our customers are doing in production is they're using Eve to manage the device. They're using Eve to specify which workloads get done, push security patches, do configuration. And then once those apps are up and running, they'll use a tool like Fledge to connect southbound, northbound, do filters, all the great stuff Ashwin just talked about. In effect, collect and manage that data on top of the Eve platform. And then obviously, it's generally not just those two technologies you see at the edge. You'll probably want a system of action or some sort of alerting functionality. You typically see a commercial firewall to protect these devices because they live outside the data center. You typically see some sort of wide area connectivity, SD-WAN style technology that allows you to manage the networks on top of these devices. So think of it as almost like a little mini cloud platform running on a single device in lots and lots of locations. And that's sort of the Eve component and how it interacts with Fledge. Ashwin, anything to add to that?
Yeah, our Fledge software is on the application layer. And like I said, we're a Swiss Army knife to create new applications out at the edge. But fundamentally, in the industrial sector, we're creating industrial data pipelines, a data fabric at the industrial setting. Fundamentally, when we start a project, we need to be able to be run in a secure environment. Now, Fledge itself and what it does create secure connections between our data sources, within Fledge itself, securing the application, securing our connections, and so forth. But we need to be able to run in a host environment that's secure as well. And in the industrial setting, it's more than necessary. It's a requirement, especially in validated manufacturing environments. In remote sites, as Maxey said, it's a requirement to be able to run in a secure environment in that way. And so, though Fledge is secure from an application perspective, our host environment and the gateways that we run on need to be secure, and that's really where Eve brings their capabilities to be able to secure that portion. Yeah.
Fantastic. Awesome. And one question we just received on Eve: how does Project Eve platform handles device provisioning and secure connection from edge to cloud?
Yeah, so great question. As I mentioned, Eve was sort of purpose-built for the edge. So we, secure the device itself using a TPM. A TPM is a piece of hardware built to store secrets. So we leverage the TPM for storing certificates, for identifying the device, as well as securing measured boot values, which are values which sort of tell you the stack of your software. So Eve has this built-in capability that runs at provisioning as well as periodically. It in effect measures each stack of the software. So it'll basically do a checksum of the operating system, of the applications, of the whole stack, and it will compare those to the expected values that you store in the cloud. And if for some reason they don't match, then one of two things happen. Either your device was hacked, or you're potentially misentered the information into the cloud. And the reason we use measured boot is when one of these events happen, it doesn't brick the device. If you're using secure boot, you basically brick the device and have to insert a new USB key to restart that device. With measured boot, what we do is we encrypt the drives and we put the device in an offline state. So this gives you the ability to kind of come back and fix those errors. So we have a very secure workflow around provisioning that again leverages this measured boot and certificates to identify the device. And then the connection itself to the cloud is HTTPS. So it's a port 443 outbound connection to the cloud. And then all of that is maintained over that connection. So we don't ask for open firewall ports or SSH connectivity. Instead, that secure connection is the port 443, and all of the communication is a pull-based architecture. So as your devices go offline, for example, if they're in a remote area where maybe you don't have cellular coverage, they continue to function. When they come back online, they'll run through that security piece. They'll ensure the integrity is complete, and then they'll pull down new configurations and make that happen. So it's to use industry terms, it's a zero-touch workflow, meaning you don't need an IT person on site. And it's also a zero-trust workflow, which means that, using this TPM and measured boot, we only trust what is attested in the cloud, and it really prevents sort of spoofing or maybe software injection into these devices. Good question, Felix. Thank you.
Awesome. Thank you, Maxey. All right. I see we have another question coming in around Fledge. So do you install Fledge as a VM and then have plugins running within as containers?
So Fledge runs within containers, VMs, whatever it may be, but it wouldn't be installed in a VM and then have separate containers. It would be installed in a VM as a whole, and then the plugins would be installed on the VM as well. Same thing and we have container images that are Docker images that are public too. But within a single container, you would install Fledge core, which is all of the microservices installed and configurable through the REST API, and then you would install the plugins within that same container image, so that by the time you start using Fledge, either through the GUI or through the REST API, you can configure and launch your SAL services with those plugins. So it would be everything installed in a VM or everything installed in a container.
Awesome. And one follow-up question from me is, sounds like there are a lot of inquiries on Eve and Fledge, which is great. It's also the reason why we're hosting webinars like this. So if folks have more questions on those two projects, where should they ask those questions to?
I think there's a number of places. I mean, obviously, you can go to our GitHub repos and post an issue. There is a LF-Edge Slack instance. You could join the Slack instance and pose a question in the help channel or in the project channel. You could email the projects themselves. There's also weekly TAC meetings, which is the technical community coming together. So there are several ways really to interact with the community. And obviously, if you want to get hands-on, you can try the sandbox and try the software out for yourself in a really easy and transparent way. Ashwin, I'm assuming Fledge has the same sort of
exactly the same as well. And if you want to put a face to it, you could always reach out to me on LinkedIn as well.
Yeah, and likewise for me around ZEDEDA and or Edge or Eve.
Fantastic. And speaking of LF-Edge Sandbox, so the LF-Edge Sandbox sounds like a great resource for hands-on experimentation. So what kind of experience can developers or operations teams expect when they use LF-Edge Sandbox to test Eve and Fledge integrations?
Yeah, I mean, it's designed to get you quickly up and running, right? So what we're trying to avoid is, when you embrace a new open source project, you have to learn a fair amount about it. Often you have to download, configure, maybe even build artifacts before you're up and running. So the sandbox is really a goal to really accelerate that time to value, right? In general, you should be able to sign up. If you have your own device or check out a device from the LF-Edge team, like you should be able to be up and running and have apps going in under an hour, right? So this is sort of saves you the effort of maybe having to dig into the docs and configurations and building different things. Like it's a turnkey experience that gets you quickly to the value, which is these applications running on top. Eve is also a very important part of the stack, but if you want to experiment with data flows and Modbus and sort of push things to Azure Cloud, as Ashwin just demoed, it's no longer a half-a-day exercise. It should be able to happen really quickly. And that's kind of the purpose of the sandbox, is to allow people to experiment and do it in a really fast, productive manner.
Awesome. Thank you. And Ashwin, do you have anything to add to that?
No, that's exactly right. Oftentimes to the point of how soon can you get up and running to actually get your hands dirty, to get a feel of the products, the services, and the value without noise. And that's what the sandbox is to get you there much more quickly and see how you can use these services in your own setting without actually having to do all of that lifting.
Yeah, and maybe the final benefit, which I think might resonate with the audience, is it also doesn't come with salespeople and marketing, right? This is an LF Edge resource. You're not signing up for a commercial demo. You're not signing up for a sales call. It's experimentation by developers for developers. So, it's an open way of consuming open source.
Fantastic. Love it. Awesome. I think that's all the questions we have. And thank you all again for the great presentation and your time and sharing your expertise with us today. And thank you everyone for attending and asking questions. So if you're inspired by what you've heard and want to get more involved, we invite you to join the LF Edge community. Whether if you are a developer, contributor, or organization, there is a place for you to engage and make an impact. And again, the recording of today's webinar will be available on LF Edge YouTube channel. We also have more exciting webinars coming up this year. So be sure to follow the LF Edge LinkedIn page and subscribe to the LF Edge newsletter to stay in the loop. And thanks again. We hope to see you at a future LF Edge event.
Thank you.
Thank you.